the previous videos, we mentioned about the heavy structure lab, which is the facility to conduct full-scale structural testing for civil engineering structural elements. We mentioned about the strong floor system, strong wall system, as well as the portal frame system. We know that the portal frame system is an assembly of standardized steel section in order to stabilize the test specimen, as well as for the positioning of the hydraulic jack system or the actuator system. You know that the strong floor system, strong wall system, as well as the assembly of the portal frame system, they have something in common when they are standardized spacing in terms of the fastening hole as well as the bolt holes. This allows the highest degree of flexibility in terms of different kinds of loads to be simulated onto the test specimen. The strong floor or the strong wall system allows various kinds of portal frame to be installed onto it to generate resistance to different kinds of loads that needs to be added onto the specimen. And the portal frame assembly members can be assembled together in various forms to resist the loads as well as to support the system throughout the testing. This is very much dependent on the load that you need to simulate, the design of the specimen, which is commonly known as the test setup. Under different circumstances, with the availability of the certain facilities, as well as depending on the actual situations that a researcher would like to simulate, the test setup will differ significantly. The ultimate goal of having this test setup is to facilitate the experimental process so that the specimen can be safely tested, protecting the researcher, personal safety, protecting the equipment, prevent any unnecessary damage of the equipment, as well as to ensure the proper testing of the specimen with good consistency so that good and reliable result can be obtained. In most of the structural engineering studies in civil engineering, especially when you deal with the experiment, the test setup needs to be properly demonstrated in the chapter methodology. You need to provide details, how the test was conducted, what kind of specimen are you testing, what are the testing apparatus, what are the measuring instruments, geodata acquisition systems, as well as the other support systems. All this will add together as a system so that the experiment can be conducted smoothly, safely, and yields you a good result. These are some typical examples of the test setup which we can obtain from the internet, done by some researchers. For example, this is the portal frame. This is the test specimen. There will be support system for the test specimen. There will be hydraulic jack system to apply loads onto the specimen, as well as the measuring instrument such as load cell, as well as the LVDTs. The load cell is used to measure the loads acting onto the specimen, which is normally placed between the hydraulic jack and the specimen. And the LVDTs are normally used to measure the vertical displacement. All these measuring instruments are connected to a data logger system and the computing system in order to monitor the result at real time. This is another example here. You have your test specimen here. There is an actuator to apply horizontal load onto the specimen. When this actuator is installed onto the reaction wall or the strong wall, and there will be some precautions to protect the actuator in case of any accident happen in order to prevent the actuator to fall. You know that the test setup needs to be properly designed. You will need to consider the space available for the testing of the specimen, as well as for the installations of the instruments, especially those measuring instruments. These are several considerations that you can take into account when you want to design an experimental setup. First, you need to know the purpose of the experiment, what kind of load that it intends to simulate. It will involve proper analysis of the actual situations and then convert it into lab testing, which is manageable, retaining the significant part of the actual situations, so that whichever simulations done in the experiment, it will be about equivalent to the actual situations. You will need to consider the availability of the facilities, instruments, space, and etc. Not all universities have all the equipments available. Even the university have all the equipments available, there could be many researchers using the similar equipments. You will need to check the availabilities of those equipments, and you will need to consider the space. Not only the working space, not only the space for you to install the testing apparatus or measuring instruments or the hydraulic jack system, you will also need to consider there is adequate space for you to take good photos of your testing. What you see here, most of the testing here are quite nicely designed to see the entire test setup clearly, as well as to see the specimen clearly. By all means, you will need to make sure that your portal frame design try not to block the view of the specimens, because another significant part of the test specimen is to observe the damage, cracking, as well as the failure modes of the specimen during the experiment. Although these two test setups are similar, both are using two separate portal frames. One is to stabilize the specimen, another one is to apply the loads. In terms of the space used, in terms of the quality of photos to be taken, this will be slightly better than this. At least the significant part of the connection here is not blocked by any of the portal frame, which in comparison to this setup, you will have a C channel just nicely block the regions of the connections at the column here. You can still take a photo in terms of the failure modes, especially immediately after the experiment has completed, but the photo will only show the part within the beam, but unable to show the part of the connections within the column. Personally, I would prefer this better as compared to this. This is of course when you have the luxury of space allocated to you. Therefore, if you see this kind of test setup, they look just nice after you done the experiment. You can take good photos of the specimens. How does it look like before and after the experiment? Next, you will need to consider the cost. You know that fabricating this specimen will incur costs, which is not cheap. And when you want to deal with the full-scale testing in the heavy structure lab, most likely you require the support of the research grant. As you are not talking about 1 to 2 specimens being tested, most likely there will be several series of specimens to be tested for the postgraduate studies. There will be costs incurred to the specimen, as well as there will be costs incurred onto the facility being used to conduct the specimen testing. You will need to make sure you can achieve your experiment objective or the purpose with the minimum cost as possible. You have to consider the safety part of it, both in terms of the peoples and the equipments. As demonstrated here, you don't want to cause any damage to the actuator. You always prepare a safety measure here, just in case anything happen accidentally, probably due to the losing of some bolted system. At least you have something to protect the actuator. The same concept applied. Always provide some safety measures. It is dependent whether this hydraulic jack system is properly installed onto the portal frame, or it is just being put without being fastened to the portal frame. Your best option is it should be properly fastened to the portal frame. If not, you will require some safety measures to hold the hydraulic jack in case of any falling of the hydraulic jack. Same goes to the load cell. You will have to be careful with the standard operating procedures, proper installations, and you will need to do routine check on your test setup. Make it a standard procedures of you. Work out a checklist for the routine check before and after you have conducted the experimental test on your specimen. If necessary, you may need to assemble your own portal frame. You will model the assembly in 3D, and also you might need to fabricate the testing jig yourself. It is always good of you if you could model it in 3D in order to observe the space available within the testing. You might also need to check if involve the actuators which are already fixed in their positions, the maximum allowable slot within the actuator. It is related to the accessibility of the actuators to your specimen, and you are recommended to refer to the relevant standards for the test setup, for example ASTM, BS, and etc. There are some standard tests quite well established, which you can follow strictly the guideline given in those standards. Sometimes if you need to conduct certain tests where there is no standard test setup, it is also always good for you to refer to the relevant standard similar to the one that you would like to simulate. Adopt their principles in terms of the setup, safety precautions, and etc. You may also refer to the relevant publications or similar tests for you to get an idea how you're going to have those specimens to be tested safely. Normally all this will be given in details in a proper research article. This is so that you can replicate the test, or you can actually adopt their concept, modify it, and develop your own test setup. Here are several examples of the test setup. In this case, there is a testing of a simply supported beam where there is a vertical load applied onto the specimen. There will be pressure sensor or load cell to measure the load. The load is distributed into 2-point load acting onto the member, and there will be rocker support at the specimen here. The effective span between the support is indicated. There will be displacement transducer to measure the displacement, one at the midspan, two under the point load acting onto the member. There will be another two LVDT here as a monitoring purpose to ensure the specimen tested under proper conditions, respond under the anticipated situations. Should any of those data indicate unlogical reading, you will have to be careful with the testing. It could be an indication of the failure of the test setup. Same goes to the testing of the portal frame. It is always a good practice of you If you have sufficient measuring instruments, such as you have some extra LVDTs, you can actually install them onto the portal frame, such as the horizontal position here, as you might not be able to assume that proper bracing will result to perfect lateral resistance without any horizontal deformations. If you notice some unusual response in terms of the portal frame, as a precaution measures, you might need to call off the experiment, and most likely your specimen, if being tested halfway, is unable to be used again. The safety, it will be the utmost concern in the laboratory. Whichever damage caused onto the specimen, you can always redo it, but in case of any accident happen in the lab, that is going to be a big deal. Always the safety is the top priority. And you will see some shrinkage onto the specimen here. This kind of shrinkage are installed on the surface of the concrete in order to monitor the crack. You may also see some other test setup, which in this case, there will be lateral load applied onto the structure here. This will generate horizontal deformations of the column and generate moment acting onto the joint here. This will be a rigid link. Whichever loops acting by here as a reactions to the beam, it will be responding to the loops applied by the actuator here. Whichever your load setup is, you will have to indicate it clearly when you want to present it in your thesis. All the necessary details should be given. The schematic drawing need to be properly leveled. Dimensions are to be given. The support conditions are to be clearly indicated. You will need to explain the entire test setup and how the experiment is being conducted. You need to provide sufficient information to the readers to be able to replicate your testing.